a NoSQL database from clients. I mean, in terms of administration and operational tasks, it advertises itself to be very fast. In addition to that, it also offers seamless scalability, and and it has the ability to do live partitioning, which means that it can scale while it is running. Um, and this is how it is linearly scalable. It has a very flexible data model. It does not have a schema, so that lets you have a pretty flexible data model, and that also means that you can remove and add fields without much of a ceremony. It also has the capability to do data migration from and to DynamoDB. And the claim of Amazon is that irrespective of the size of the data, the latency of read and write would always remain in milliseconds. So why do we need NoSQL? So in a traditional database, the applications do not provide stable, consistent, and predictable performance. As the number of users increases, right, the complexity of queries increases as the scale increases. So basically, number of with the increase in number of users or the complexity of queries, the scale drops consistently, and that is kind of depicted in the graph here, where performance is no longer consistent as the number of users increases. And this gap, which is shown in red, is usually addressed by adding more hardware or add more of data sharding. But clustering and fault management can address some of the issues, but it does come at a pretty high cost. And as the number of users or the queries get more and more complex, you continuously would have to feed more resources into the system. So NoSQL database has been found to address some of these issues, and and promises to provide consistent performance irrespective of data size. This is primarily because Amazon DB is based on partitioning, and it is a very distributed hash table. It has an extremely fast performance and seamless scalability. Um, since it runs on solid state drive, the read and write are extremely fast. And a transaction is not supported, so it does not fit everywhere. So when you actually decide to choose DynamoDB, you got to consider the fact that transaction is not supported and it may not fit everywhere. So in the next set of slides, I will go through the DynamoDB database design, and I will take a real application which will display some of the operational tasks like query and updates. In that context, I will explain the data model. At the end, I will wrap up the discussion with Elastic MapReduce. So let us have a closer look at the DynamoDB model. All NoSQL databases are flexible and have no schema, and this is how DynamoDB works as well. It works like all NoSQL databases in a sense that it is based on a simple key value pair. So in this case that you are seeing here, an item has a key name with a value as Rajesh Kavedi. Similarly, class is another key with which has a value of CSIE Harvard. So if you are a developer, and you can see that it is essentially an associative array or a hash map. So in DynamoDB parlance, it is described as key and attribute. And you can see that one of the items in this table was me, and I was the presenter. Now, if I actually decide to add another entry, which is a speaker and does not have a presenter field, you can add a new attribute called C. And as you can see that I don't have to create a new table or migrate this data, but rather I'm able to evolve this table and just add another attribute. So recapping, all these collections of attributes are items, and items are grouped together to form tables. There are no limits on the number of items a table can store, but there are limits in terms of how much data can be stored within an item. Data can be accessed using primary key or a primary and range key called composite key. These are the only attributes that are indexed, and that means that you can run queries on those range keys. So in this example, I can run a query to get the data for customer in a specified date range. So before you start creating a table, you need to make certain decisions on how your table will store its index. DynamoDB has a key attribute data where each item in the table can be retrieved by this key. This key is called primary key, and in this example shown above, name is the primary key, and you can retrieve your item using the name as the primary key. So then there's other primary key which is called hash and range type primary key. In this case, primary key is made up of two attributes, a hash attribute and a range attribute, as I explained before. DynamoDB builds an unordered hash index on this primary key attribute and a sorted range index on the range primary key. And if you want to apply or you want to run a query, you have to supply a range attribute, because primary key would be able to just give you a get functionality, but if you want to run a query, you have to supply a range attribute. In this example, there are a list of replies where ID identifies the thread to which it belongs, and that is the primary key. Reply date time is the range attribute, and that can be used to select a set of replies within a specific time range. So the example that we're going to run through, I'll take a specific example which is familiar to many of the developers. Here I have a development forum where user can start various threads. On these threads, communities can reply to those threads. And I will use these tables to demonstrate good practices, updates or queries, and use the product table to demonstrate MapReduce. As part of the same data model that I just talked about, if you look at it, the forum has a primary key, a hash attribute of name, and it is basically a hash type. A thread is a hash and range, where hash attribute is the forum name, and the range attribute name is subject. And in the thread table, or rather reply table, you have hash and range, where one of the attributes is ID and the second attribute is reply date time, as I talked earlier. To execute the MapReduce, we are also going to create a product catalog table on which we will do the MapReduce functionality. In terms of schema, this is how it's going to look like. You have forum, and forum then has a dependency on thread, where thread is using the forum name as the primary key and the subject as the range key, and then reply uses the ID, which is basically a composite of forum name and the thread ID. Within Amazon DB, you can store the data as strings, numbers, or binary, and you can store collections, or you can also store collections of the data set. Now, there are some good practices that you need to follow. One of them is design tables so that hash key has a large number of distinct elements. So you do not want to create a primary key which has a lot of duplicates. So for example, if let's say you have an iPhone 5 as one of the keys and iPhone as another key, it is likely that many of the users would have iPhone as their device. So you want to make sure that you don't have too many of users having the same key. So let's say if this table has many iPhone 5s, you would have problems in terms of getting the data set, and it does make the whole query part more expensive. Instead, you want to make sure that you create a distinct key, and the way you would do it is you can append some value to that key, which is indicative of the user who's trying to access this. So for instance, let's say if a user has A as his first name, you might want to make iPhone 5.a as the key, which would make the key more distinct. In addition, there are times when you load data from other data sources into Amazon DynamoDB, and typically DynamoDB partitions your table data on multiple servers. So when uploading data to a table, you get better performance if you upload data to all allocated servers simultaneously. So for example, if you want to upload user messages to Amazon Dynamo table, you might want to design a table that uses hash and type range primary key, in which user ID is the hash attribute and the message ID is the range attribute. But when uploading data from your source, right, you might tend to read all messages item for a specific user and upload these items to Amazon DynamoDB. So what results in is that it may not be very efficient, because now um, you are loading one user at a time, and essentially if you're taking one user, you are focusing all your load into one partition. Instead, you want to make sure that user base would have better distribution of load, and you get all the partitions getting utilized while you're uploading the data. So if you can load data for user 1, then load 2, and then user 3, that way you essentially would be in a position to use all the partitions more effectively, and your performance would be much better. Um, in addition, there are some other considerations. I will not go into the details, but something to think about: time series data, where you want to make sure that typically in time series data, you want to really work with the latest data, and you probably may not be interested. So in that scenario, it makes a lot of sense to move that data set to a separate table. That way, other tables would not get impacted due to certain data set to be hard. If you store replies, in this scenario where you are seeing you have threads and replies, so if you store replies as an item in table, you can store any number of replies, because an Amazon DB can store any number of items. But if you store replies as an attribute value in the thread table, you would be constrained by the maximum item size. So you do not want to have the reply as an attribute of thread. Rather, you would want to create two distinct tables of thread and reply. In addition to that, if you frequently access large items in an Amazon DynamoDB and you do not always use all of the items larger attribute, you can improve your efficiency and make your workload more uniform by storing your smaller, more frequently accessed attribute as a separate table. So in this scenario, price might be a good candidate to be stored in a separate table, where the description is a more static and all the static information can be put together as one table. So in that scenario, you would create a different provision throughput for these two different tables. DynamoDB has a pretty simple API. There are overall 12 operations that include creating a table, updating a provision throughput, and delete the table. You can do many item level operations, which include update, delete, create item attributes. And one of the point that might be relevant here is that DynamoDB guarantees transactional consistency at item level. So if all attributes cannot be updated, the operation would fail. So in that scenario, there is some level of consistency in NoSQL as well. In terms of get, there are two main types of get. One is the query and the scan. A query do searches only on the primary key attribute, and it returns all item data for matching primary key till result set is exhausted, or items have reached the limit boundary that users provided when executing the query, or amount of data has reached 1 MB of data. So Amazon DynamoDB has a limit of 1 MB per query. So if your data set is more than 1 MB, then you will have to execute another query. So a range key is the only index key in the Amazon DB and can be used for filtering the data. So that is the main difference between using a range key versus just a primary key.